Hello students, hi everyone. Once again welcome to our channel Competitive Maths by Balaji. Today we are going to look part 8 of rational numbers is about the representation of rational numbers on the number line. In previous year classes in 6th 7 we learned that how to represent natural numbers, whole numbers, integers on the number line. Now in part 8 of rational numbers let us recall them. Okay, right. Which set of numbers marked on the number line? So consider a number line. Okay, some points are labeled on the number line, and this point denotes 1, 2, 3, 4, 5, and so on. Which set of numbers these are? These are all natural numbers. As natural number starts from 1, 2, 3, 4, and so on dash dash dash. Okay. Now question is that is there any natural number between 1 and 5? Between 1 and 5. How many natural numbers do we have? 2, 3, 4. Yes, 3 natural numbers are there. They are 2, 3, 4. The natural numbers between 1 and 5 are 3. Okay. Now, the next question is that is there any natural number between 1 and 2? Between 1 and 2, there is no natural number exist on the number line. So answer is no. There is no natural numbers between consecutive two natural numbers. Why? Because the natural number succeeding to 1 is 2 and the natural number preceding to 2 is 1. So there is no natural number exist between two consecutive natural numbers. Okay, right. Now include 0 on the number line. Now which set of numbers marked on the number line? As number line starts from 0, 1, 2, 3, 4, 5 and so on dash dash dash. These set of numbers are called whole numbers. These set of number lines are called whole numbers. Now see, between 0 and 4, between 0 and 4, how many whole numbers are exist on the number line? So simply 1, 2, 3. 3 whole numbers are exist between 0 and 4. Okay. Now the question is that between 0 and 1, between 0 and 1, is there any whole number between 0 and 1 on the number line? Nothing between 0 and 1, because the whole number next to 0 is 1 and the whole number previous to 1 is 0. So there is no natural number between two consecutive natural numbers. Also, there is no whole number between two consecutive whole numbers. These are the points very important. Okay. Now, next. So, label there -1, -2, -3, -4, -5. Okay. Now, which set of numbers these are? Now, which set of numbers marked on the number line? As we have negative, 0 and positive. The collection forms an integer or Zahlen number. So, the set of numbers marked on the number line are represents integers. Now, the between -3 and 3. Between -3 and 3. How many integers are there on the number line? Between -3 and 3. How many integers are there on the number line? As we know that simply -2, -1, 0, 1, 2. There are 5 integers between -3 and 3. There are 5 integers between -3 and 3. Now question is that how many integers are there? How many integers are there between -3 and -4? Between -3 and -4. By observing the number line, no integer is exist between -3 and -4. No integer is exist between -3 and -4. That is, we make a note point that there is there is no natural number exist between consecutive two natural numbers. Similarly, this property holds true for whole number as well as integers also. There is no whole number exists between consecutive two whole numbers. Similarly, there is no integer exists between consecutive two integers. Okay, these are all about natural numbers, whole numbers, integer. Now, example find the textbook is that identify the rational numbers. Shown A and B. We have to identify these two rational numbers shown by A and B marked on the following number line. So this is a number line considering from 0 to 1, that is 1 unit length. This is called 1 unit length. 1 unit length of number line. 1 unit length of number line. Okay, this is 0 to 1 is 1 unit length. Now, 1 unit length is divided into how many equal parts? Let us see. This is first part, second part, third part, fourth part, fifth part, sixth part, seventh part. So that one can be written as out of 7 equal parts, it is seventh part. 1 unit length on the number line is divided into 7 equal parts. Out of 7 equal parts, 1 is seventh part. That is 7 by 7 is equal to 1. So the 1 unit length is divided into 7 equal parts. So the denominator is always 7. The denominator is always 7 for A and denominator 7 for B also. Now out of 7 equal parts, which part is taken as 1, 2, third part. So fraction value of A is 3 by 7. Our rational number that shows A is 3 by 7. Similarly, out of 7 equal parts, B is marked as 1, 2, 3, 4, fifth part. So the rational number shown by B is 5 by 7. See, from this example, we can make a note very important. That is, in a rational number, the denominator tells us number of equal parts in which each unit has been divided. So the denominator of B is 7 and denominator of A is also 7. So denominator tells us the number of equal parts in which each unit is divided. So here 0 to 1 unit length is divided into 7 equal parts. That is our denominator. So in a rational number, the denominator tells us number of equal parts in which each unit has been divided, and the numerator tells us how many of these parts are considered. Okay, see here 0 to 1 unit length is divided into 7 equal parts. Out of 7 equal parts, A is taken 3 parts and B is taken 5 parts. So fraction value that's shown by, or so the rational number that's shown by A is 3 by 7 and that's shown by B is 5 by 7. Okay, so in this way we have to represent the rational numbers on the number line. Next, example 6. Represent 5 by 8 on the number line. Represent 5 by 8 on the number line. So consider a number line. Since 5 by 8 is an proper fraction, and we know that every fraction is a rational number. The 5 by 8 value lies between 0 and 1, as every proper fraction lies between 0 and 1. So that 5 by 8 is also a proper fraction, and we know that every fraction is a rational number. So that the rational number 5 by 8 lies between 0 and 1. Now consider 1 unit length from 0 to 1. As here denominator is given by 8, so divide this 1 unit length into 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. So 1 can be written as 8 by 8. Eighth part out of 8 equal parts. 0 can be written as 0 parts out of 8 equal parts. So now we have to take fifth part out of 8 equal parts. 1, 2, 3, 4, 5. So this is 5 by 8. Okay. This is the representation of 5 by 8 on the number line. Next example 7. Represent 29 by 6 on the number line. But we know that 29 by 6 is an improper fraction. 29 by 6 is an improper fraction. And every fraction is a rational number. So that 29 by 6 can be expressed in terms of mixed fraction. Since 6 fours are 24 and 5 is remainder. So that 29 by 6 can be expressed as 4 whole 5 by 6. Also, 4 whole 5 by 6 can be written as 4 plus 5 by 6. The fractional value 5 by 6 added to 4. So, the value of 29 by 6 is more than 4 and less than 5. So, the value of 29 by 6 lies between 4 and 5. Okay. Now, consider the 1 unit length between 4 and 5 on the number line. So this is 4 and this is 5. Since denominator is equal to 6, denominator shows that the number of equal parts in which each unit length divided on the number line. So denominator is 6. Divide the 1 unit length between 4 and 5 on the number line into 6 equal parts. 1, 2, 3, 4, 5, 6. So these are 6 equal parts. Out of 6 equal parts, mark fifth part. Mark fifth part. So that is, this is first part, second, third, fourth, fifth part. So this can be equal to 29 by 6. As we know that 29 by 6 value lies between 4 and 5. After the 4, it is a fifth part out of 6 equal parts. So answer is 29 by 6. Okay. Now try this, do this in the textbook. Write the rational numbers for the points labeled with letters on the number line. Each and every 1 unit length of number line divided into 5 equal parts, as denominator is 5. So A is next to 1 by 5, 2 by 5, 3 by 5. B is 4 by 5. C is 5 by 5. That equal what? 1. Next 6 by 5, 7 by 5. E is 8 by 5, 9 by 5. F is equal to 10 by 5, which is equal to 2. Okay. Now the number line has 2 unit lengths, 0 to 1, 1 to 2, and each unit length is divided into 5 equal parts. Out of 5 equal parts, this is 0 part, first part, second part, third part, fourth part, fifth part. So fifth part out of 5 equal parts is denoted as 1. Similarly, this is sixth part, seventh part, eighth part, ninth part, 10th part out of 5 equal parts. That is 10 out of 5 equal parts is equal to 2. Okay. And second one is homework for you people. Try by yourselves. Do this. Represent minus 13 by 5 on the number line. Since minus 13 by 5 can be written as minus of 13 by 5. That can be written as minus of 2 whole 3 by 5. As we know that 5 2s are 10 plus 3, 13 by 5. That is negative 13 by 5. So this can be written as minus of 2 plus 3 by 5. That equaled minus of 2 minus 2, minus of plus minus 3 by 5. So we are subtracting 3 by 5 from minus 2. So its value less than minus 2. That's it. That is, the value of minus 13 by 5 lies between minus 2 and minus 3 on the number line. So consider the 1 unit length between minus 3 and minus 2 on the number line. Since we are subtracting 3 by 5 from minus 2, so its value, whole value of minus 13 by 5 is less than 2. That is, lies between minus 2, 3 and minus 2, or minus 2 and minus 3. Now see, our denominator is 5. That is, denominator shows that how many equal parts in which the 1 unit length divided on the number line. That is, we have to divide this 1 unit length. We have to divide this 1 unit length into 5 equal parts. That is 1, second part, third part, fourth part, fifth part. This is 0th part. 0th part, first part, second part, third part, fourth part, fifth part. Okay? Yes. From left of minus 2, we have to consider third part out of 5 equal parts. See, this is 0th part out of 5 equal parts. This is first part out of 5 equal parts. Second part out of 5 equal parts. Third part, yes. This is minus 13 by 5. Okay. So, in this way, we have to locate rational numbers on the number line. Next concept is that rational numbers between two rational numbers. Before that, let us observe the following statements. The natural number between 1 and 5 are. What are the natural numbers between 1 and 5? Between 1 and 5 we have 2, 3, 4. 3 natural numbers between 1 and 5. The integer between minus 4 and 3, they are minus 3, minus 2, minus 1, 0, 1, 2. The integer between minus 1 and minus 2 not exist. That is, not exist. As we know that between two consecutive integers there is no integer. Okay, between two consecutive integers there is no integer is exist. So the integer between minus 1 and minus 2 is not exist. Right. Next, the rational number between 2 and 3, where 2 and 3 are integers, also rational numbers. So the rational number between 2 and 3, we have a formula, that is, if A and B are two rational numbers, A and B are two rationals, then average of A and B, that is sum by number A plus B by 2, is a rational number, is a rational lie exactly between A and B, between A and B. That can be written as, that is, A plus B by 2 is a rational number that is lie exactly between A and B, that is A less than A plus B by 2 less than B. Now this can be also written as, if A and B are two rational numbers, then sum A plus B is divided by their number 2 is a rational number lie between A and B. In other words, it can be written as, i.e., the rational number lie between A and B is A plus B divided by 2. A plus B divided by 2. So the rational number lie between 2 and 3 is equal to 2 plus 3 is divided by 2. 2 plus 3 means 5. 5 divided by 2 can be written as, that is 5 by 2, which is exactly middle of 2 and 3. So this is 5 by 2. The rational number which lies between 2 and 3 is 5 by 2. That is 5 by 2. Now we can find another rational number between 2 and 5 by 2. See, the rational between 2 and 5 by 2 is, consider the sum 2 plus 5 by 2 divided by numbers are 2. Okay, sum by number, that is average. Yes, 2 2s are 4, 4 plus 5, 9 by 2 divided by 2. That is 9 by 2. Division symbol may change into multiply quantity. Consider the reciprocal of 2, that is 1 by 2. 9 ones are 9 by 2 2s are 4. So the number 9 by 4, is lies exactly between 2 and 5 by 2. So the number 9 by 4 is lies exactly between 2 and 5 by 2. Similarly, we can insert another rational number between 5 by 2 and 3. So that between 2 and 3, we can insert infinitely many rational numbers. Between two rational numbers 2 and 3, we can insert infinitely many rational numbers. This property is called dense property of rational numbers. Let us see what is dense property of rational numbers. There are infinite rational numbers between any two given rational numbers. This property of rational number is known as the dense property. So in the similar manner, we can insert another rational number between 5 by 2 and 3, and another rational number between 9 by 4 and 5 by 2, another rational number between 2 and 9 by 4. So that can be written as, between two rational numbers, there are infinitely many rational numbers can be inserted. This property of rational number known as dense property of rational numbers. Let us see another example. Says, can you write 100 rational numbers between 5 by 10 and 9 by 10 in this average method? We can write, but it is lengthy process. Let us see alternate method. That is alternate method. We have to insert 100 rational numbers between 5 by and 9 by 10. Since 5 by 10, 9 by 10. Between 5 by 10 and 9 by 10, we have to insert 100 rational number. So that make it by 50 by 100, 90 by 100, which is equal to 9 by 10, which is equal to 5 by 10 also. Between 50 by 100, 90 by 100, as they are like rationals. Between 50 and 90, we can insert the rational numbers 51 by 100 dash up to 89 by 100. We can insert 39 rational numbers. We can insert 39 rational numbers between 5 by 10 and 9 by 10 now in this way. But we need to insert 100 rational numbers. We have to write 100 rational numbers between 5 by 10 and 9 by 10. So that 5 by 10 can be expressed in the terms of equivalent rationals 500 by 1000. Similarly, 9 by 10 can be expressed as 900 by 1000. So that now we can insert 501 by 100, 1000, 502 by 1000, dash 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 dash, 898 by 1000, 899 by 1000. So we can insert 399 rational numbers between 500 by 1000 and 900 by 1000, where 500 by 1000 that means equal to 5 by 10, 900 by 1000 is equal to 9 by 10. So we can choose any of 100 rationals among these rationals. Okay, In this way, we can insert 100 rational numbers between 5 by 10 and 9 by 10, which is called alternate method, equivalent rational method. Okay. Next question, example 8. Write any 5 rational numbers between minus 3 and 0. Write any 5 rational numbers between minus 3 and 0. Solution. Since minus 3 can be written as minus 30 by 10 and 0 can be expressed as 0 by 10. So between minus 30 by 10 and 0 by 10, we have minus 29 by 10, minus 28 by 10, minus 27 by 10, dash 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 dash, minus 3 by 10, minus 2 by 10, minus 1 by 10, and then 0 by 10. But we have to insert only 5 rational numbers between minus 3 and 0. So we can take any 5 of these. Any 5 of these. Okay. Right. This is the method to insert a 5 or 10 or 20 or 30 rational numbers between given two rational numbers. Next, exercise 2.2. Represent these numbers on the number line. Consider a number line. First one, solution. As denominator is 7, numerator is 9. That is, numerator is more than denominator. So it is an improper fraction. This can be expressed as 1 whole 2 by 7. That is 1 plus 2 by 7. So it lies between 1 and 2. So the value of 9 by 7 lies between 1 and 2. As we are adding a fractional value to 1, that is more than 1 but less than 2. Okay. But denominator is 7. So we have to divide this 1 unit length into 7 equal parts. That is 1, 2, 3, 4, 5, 6 and 7th part. After the 1, we have to choose second part out of 7 equal parts. After the 1 on the number line, we have to choose second part out of 7 equal parts. So this is first part, this is second part. So this is 9 by 7. So 9 by 7 lies between 1 and 2. And second one is homework. Also, second question is also homework for you people. And see, fourth one is also homework for you people, as it is equal to 8th model. Okay. Next, third question. Write 5 rationals which are smaller than 5 by 6. Smaller than 5 by 6. That we can write 4 by 6, 3 by 6, 2 by 6, 1 by 6, 0 by 6. These 5 rationals are less than 5 by 6. Okay. Fifth one. Find a rational number between 2 by 3 and 3 by 4. Solution. A rational between 2 by 3 and 3 by 4. We know that a rational between a and b is a plus b divided by 2. So in the same manner, the rational number between these two is 2 by 3 plus 3 by 4 divided by 2. As we know that they are unlike rationals, by cross product 4 2s are 8 plus 3 3s are 9 by 3 4s are 12 divided by 2. 8 plus 9, 17 by 12. 17 by 12. Division symbol may change into multiply quantity. Consider the reciprocal of 2, that is 1 by 2. So 17 ones are 17 by 12 2s are 24. 17 by 24. Yes, 17 by 24 is a rational number, lies exactly between 2 by 3 and 3 by 4. Okay. Next. Find 10 rationals between minus 3 by 4 and 5 by 6. To insert 10 rational numbers between these two rationals, first of all we have to write the rationals with equal denominators. We have to convert them into rationals with equal denominators. Consider the LCM of 4 comma 6. LCM of 4 comma 6 is 12. As 4 3s are 12, 6 3 2s are 12. So minus 3 by 4 can be expressed as minus 3 by 4 into. To make denominator 12, as their LCM is 12, multiply here with 3. At the same time, multiply 3 with minus 3 also. Similarly, 5 by 6. As LCM is 12, make the denominator 12. To make the denominator 12, we have to multiply the numerator and denominator of 5 by 6 with 2. So it is equal to minus 9 by 12, which is equal to 5 2s are 10 by 6 2s are 12. Between minus 9 by 12 and 10 by 12, we can write many rational numbers like minus 8 by 12, minus 7 by 12, minus 6 by 12, minus 5 by 12, dash 0 by 12, comma dash 8 by 12, comma 9 by 12. So among all the rational numbers, we can take any 10. We can take any 10 rationals of these. Okay. So students, this completes the exercise 2.2.